feel like you make these lessons plans like fun for us. So.
Oh, thank you. Well, I try. As best we can, Spencer. As best we can. As best we can. All right, guys. All we're going to do today, all right? All we're going to do today is we're going to take these curves that we created last class, right? And we're going to start moving them around, okay? Now, what we did last class is we built the sine curve, right? And how do we build it? Well, we took the unit circle, we wrote down a bunch of points, and then we plotted them, right? Then we talked about what happens if I change the number in front. And you guys agreed that all I would have to do is multiply the y values. So what does it essentially do? It makes my graph taller, right? Or I guess it could make it shorter if I put a fraction in front, right? Between 0 and 1, it would get smaller. So my graph is either going to stretch or shrink vertically. We also talked about how a negative sign does what? Takes the graph and reflects it, yeah. So now what I want to do is I want to take a graph and I want to do this. Look, right? So I want to shift it up and down, okay? So if we go back to CBAD, which value, A, B, C, or D, would take a graph and shift it up or down? We go back to CBAD, A, B, C, or D. So if I gave you this versus this, which one of these graphs shifts up and down? Which one of these graphs shifts left and right? Which one does this do? Well, what am I doing? I'm adding one in a set of parentheses. So that's going to move things left and right. Here I'm adding one outside of the parentheses, which is going to shift it up or down. So this would be an example of a shift up or down. So if I take a sine or a cosine and I simply add a value or conversely subtract a value, what's it going to do? Take my graph and shift it up or down. Okay? So we're going to look at this as an example. Okay? So I am adding 3 to the graph, right? So based on the conversation that we just had a second ago, what do you think is going to happen? Well, the 3 is in the parentheses or out? Out. So what do you think is going to happen? Shift up or down, left or right? This is going to shift my graph up 3 units. Now, what I'm going to do is take a look at this sine curve, right? Everybody agrees this is a sine curve. I gave you guys a hint to remember whether this is a sine or a cosine curve. Always look at the origin, right? If it goes through the origin, sine. Okay, typically sine. Now you're going to see what happens right now because things are going to get messed up, right? So what am I going to do to my graph? I'm going to shift it up 3 units, which means I'm going to take these dark points, which are those key points on my graph, right, and simply move them up 3 units. So up 3 units, up 3 units. And we get that guy. That's cool, right? Guys, what was the range? When I ask you guys about range, what am I referring to? Lowest y value to highest y value, right? So if I wanted the range of sine of x, the original curve, right? If I wanted the range of the original curve, what's the lowest point on the original curve? -1. And the highest point on the original curve? +1. So the range is -1 to 1, right? Now, how about on my new red curve? What's the lowest point on my new red curve? Right here, 2. This is the lowest point, and the highest, 4. 2 to 4, right? Guys, if the let me ask you this: do you guys agree that all sine curves that aren't shifted and all cosine curves that aren't shifted have a range of -1 to 1? Okay. So if I gave you a question about range, do I really need to graph it and shift it to answer that question if I know it's been shifted up 3 units? Can I just take -1 and add 3 to get what? 2. And take 1 and add 3 to get 4. So couldn't I have just added 3 to both of these numbers to get that value? Okay, does that make sense, right? So instead of graphing it, that's the way I could have looked at the problem. All right. Here's the problem I got now, right? Here's the problem I got now. A couple of issues. Issue number 1, I don't have an original curve to look at. Issue number 2 is that value. Now, we did that last class, right? What is that going to do to my graph? It's going to stretch it, right? Stretch it vertically, okay? So this is going to stretch it by 2. So this is going to stretch vertically by 2. And this is going to shift up 1 unit. Is that cool? All right. Now, this is a cosine curve, right? Where should my cosine curve start? It's not going to start at 0, 0. It's going to start at 0, 1. Okay? Now, if I needed to, right, to get the next value, what could I do? Oh, I could create my unit circle. Correct? And if I want my next value, am I going to look at the x values or the y values if I'm graphing cosine? X values, right? So, all right, I'm looking at this number, this number, this number, and this number, right? So where does my cosine curve begin? At 1, right? Which is why I got a point at 1. Now let's work our way around this circle. What's the next x value? The next x value? 0. And then the next x value? -1. And then the next x value? 0. And then the next one? Back to 1, right? Okay, well, what if I went in the negative direction, right? What if I went in the negative direction? 1 would go to 0, would go to -1, would go to 0, would go to 1. And there's my cosine curve. All right. Based on last lesson, guys, based on the last lesson, not today, but the last one, if I want to now make this 2 cosine of x, what am I going to do? I'm going to take each of these y values and double it. So this y value, right, now becomes what? Are you guys don't got any energy today? Hang on. I'm going to ask my friend Dylan. Dylan, this y value is 1, right? If I double it, what am I going to make it? Good. This y value here is what? If I double it, it's still 0. This is -1. Double it. Very good. Okay, so go to here. This stays. This goes down. This stays. This goes here. So this is 1 cycle of 2 cosine. And then we have the second cycle, which would do the exact same pattern. Ba-boom, 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 ba-boom. And that is 2 cosine of x. But then I got to take that graph and I have to shift it up 1 unit, right? Which just means to take all of these points and literally shift them up 1 spot. So red goes there, red goes there, red goes there, goes there, and looks like this. Two cosine of x plus 1. Guys, I had a quick question. Quick question is this. We're plotting points every how many degrees? Well, we're going around the circle and jumping by how many degrees each time? How many degrees is to go from here to here? 90, right? And then it's another 90, and then it's another 90, and then it's another 90. So do you guys agree that these are jumps of 90 degrees? Okay. So one of the ways that you guys could actually go about doing this would be to do the following. Now I'm going to totally confuse you if you're not really with me, okay? All I want to graph is cosine of x to start. Now here's the problem that I have. The problem that I have is that when I hit enter, I'm going to see this. Notice a couple of things about my graph. What mode am I in? Radian mode. Now I told you guys not to worry about the mode, right? Well, when we graph, the mode's going to be really, really important, okay? So let me go back to this for a minute. If I wanted to be in terms of degrees, what would I need to do? I'd need to put a degree symbol in here. But the problem with that is now look at my graph. What happened? Well, what happened, guys, is I'm now in degree mode, which means that my what? Look at my window. This goes -10 to what? 10. If we look at my graph goes -2 pi to 2 pi. What's -2 pi the same as? -360, and this is the same as +360, right? So if I go back to this, I need to change my window to go from -360 to +360. Oops, that wasn't what I want to hit. And now check it out, right? Now it looks exactly like we hoped, right? Here's what's actually, there's a couple of kind of neat features, right? Here's one of them. If I hit Control T, we get this, right? Well, that doesn't seem all that helpful, does it? But watch this. If I change my menu and I change my table, I'm going to change the table settings. Okay? Now watch how I'm going to change the settings. I'm going to start my table at 0. Table step means how much am I going to change from one row to the next. Now we graphed every how many degrees? Every 90 degrees, right? So if I change this to be a 90, then what does that mean is going to happen? My table's going to start at 90. The next one, I'm sorry, my table's going to start at 0. The next one it's going to show is 90, and then it's going to show multiples of 90 degrees. So check that out. My graph starts at 0, 1. At 90, it's 0. At 180, it's -1. At 270, it's negative this. This is one of the things you got to be careful with the calculator. This really means what? It's -1e to the -13. That's scientific notation, right? -13 means I put zeros which way? To the left or the right? So is it a small number or a big number? Small number, right? So this is the same as -0.13 zeros in a 1. 0.00000000000001. What is that number essentially? 0, right? It's essentially 0. This is one of the things that sometimes the calculator will do, right? And we'll pick up on those little errors as we go. There's another one that's actually 0 again, and we can look at those values, right? Kind of a cool way to do it. Where are you looking? No, it's still 0. This would be -0.00000000007. Yeah, yes. It's just weird things that the calculator does, guys, which is why it's not a perfect tool, right? It's not a perfect tool. Sketch the graph of a line that this curve rises and falls 2 units above and below. Give the equation of this line. Guys, what that means is on this green graph, I'm going to ask you to do a weird thing. I'm going to ask you to cut the green graph in half. Now, the way that I want you to cut it in half is this way. Okay? So I'm imagining what you're probably doing is saying, okay, this is the highest point. Okay, this is the lowest point. To cut it in half, my line would have to be here. Would that be a reasonable thought? Yeah. So to cut it in half, it would be right here. What's the equation of that line? That's the line y equals 1, right? Do you notice how that's the same as this? Yes? Yeah. I'm going to give that a special name, guys. This is going to be called the midline. Okay? We're going to call that the midline. Now, if you look at the range of this green graph, right? Check it out. Hang on. Before we do that, do we see how this point is 2 units above the midline? Do we see how this point is 2 units below the midline? Why is it 2 units above and below? Because of the 2, right? Okay. So if you think about this, guys, the midline is at 1. If I go 2 above that, I'm at 3. If I go 2 below that, I'm at -1. So isn't the range of my green graph -1 to 3? All right, and we're going to use that concept to help us do one more problem. Okay. Well, this is the same question. That's stupid. let's change this. Oh, okay, hang on a minute. I see what they're doing. They're just saying, on this problem, what is the midline? Well, we just did that. It was what? It was y equals 1. Now, here's an easy way to do it, guys. Ready? The midline is the average of the range, right? The midline is the average of the range. So how do you find the average of two numbers? Add them together and divide them by 2. So that's another way that you can find the midline, is just to do that. Are we good? All right. One more thing. We all agree that the midline is going to be the number at the end also, right? So the midline is the number at the end. It's where I cut the graph in half. It's the average of the range. Okay, so we have a lot of different ways to find that. Okay, so here's where we're going to take all that and make our lives really, really easy now. Okay, here's F. Here's F. What is the amplitude? Amplitude means that number in the front. It's how much is my vertical stretch. So in this, the amplitude is 4. All right. Now remember what I said about the midline. The midline can always be found by looking at this number at the end. So the midline is -2. So if I wanted to graph this curve, right, I can do it one of two ways. Shay, I can do what I did on the previous problem, which is to just graph sine, then multiply it by 4, and then shift it. That's a 3-step process. If I didn't want to go about that 3-step process, what I could do is this. I could graph my midline. So here's my midline. Now, this is what kind of a curve? This is a sine curve, right? Where does a sine curve begin? At 0 or 1? At 0. Now, what I'm going to do is I'm going to pretend like my midline is 0. Everybody hear what I just said? I'm going to pretend like this is my 0. Now, what am I going to do? To graph a sine curve, I'm supposed to go what? Up, back, down, back. Agreed? So instead of going up to 1, I'm going to go up how many units? 4 units. So at 90, I'm going to go up 1, 2, 3, 4. Then where am I supposed to go? Then I'm supposed to go back to the midline. Then I need to go down how many units? 4. Then I have to go back to my midline. And what did I just create? I created how many cycles? 1 cycle of sine, because that's what 1 cycle of sine looks like, doesn't it? And then what's going to happen? I'm going to have another cycle that goes the other direction, right? So this cycle is going to go and look kind of like this. And that is f of x equals 4 sine of x minus 2. Now, maybe you looked at that problem and you said, you know what, Picardo, I kind of think I got it, but right? Maybe I'm not real sure about what you just did there. Right? So what you're going to do then, or if you really want to check your work, is you're going to go to add a calculator. You're going to type in 4 sine of x degrees minus 2. But the problem is that I can't see my graph, so I need to go to change my window, negative 360 to positive 360. Now, if I look at my paper, does my paper match up with what's on the screen? It ought to, right? Now, if I really want to make sure that my points are good, oh, by the way, if yours doesn't look like this, why doesn't it look like this? Because you didn't put a degree symbol with the X, right? Because I want to look at this in terms of degrees, right? Now, if I want to really be sure, I'm going to go to Control T to look at my table, right? Well, what's my problem? My table is jumping by how many? By 1. Do I want to jump by 1? No, so I'm going to go to Menu, Table, and change my table settings to jump by 90. I'm still starting at 0. Now, if I really didn't want to start at 0, maybe I want to start it all the way at the beginning. I'm going to start at negative 360 and jump by 90. So what's that going to do? That's going to bring me all the way to the beginning, right? So what do I got? I got negative 2 to 2 to negative 2 to negative 6. Negative 2 to 2 to negative 2 to negative 6. Back to negative 2 to get the idea, right? Now, really quickly, guys, I have totally avoided radians for the graph, right? Let's just suppose that, like, you really are like, you know what, Picardo? I really want to know about radians. I really want to know about radians. So, if you really, 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 really need to know about them, watch what I'm going to do. I'm going to go back to my graph. I'm going to get rid of this and leave just an X. But what happens is that, because now this is all messed up. Because if I'm talking about radians, look at your paper, guys. Look at your paper. What's the symbol all the way on the left-hand side? Negative 2 pi. What's the symbol all the way to the right? Positive 2 pi. Now, there it is, right? So if we want to talk radians, we can talk radians. Just make sure you're using radian in the window. If you want to talk degrees, you can use degrees. Just make sure you use degrees in the window. Is that okay? All right. Take a minute and graph g of x. Graph the other function there. All right, so Cam reminded me of a couple of things here as I was looking at what he did. Thing number 1. What's my midline? Okay. What's my amplitude? Okay, now hang on. My amplitude is 2. The negative sign means I'm going to what? Means I need to reflect it. Okay? So, still going to draw my midline. So I'm going to treat this like my 0, right? Like my axes. Now here's the deal. A cosine curve doesn't start at 0. A cosine curve starts at 1. Okay, so let's be really, really, really literal. What am I supposed to do? I'm supposed to take 1 and multiply it by the a value, right? So what's 1 times negative 2? So my graph is going to start at negative 2. Now, hang on a minute. Stop, because I got a lot of people that just raised their eyebrows. They're like, hang on a minute. Negative 2, that's not negative 2, that's positive 1. when we're doing this, we need to treat the midline like the axes, like the 0, okay? Now, again, from here, right, where does a cosine curve go? Ready? Look at my hand for a minute. A cosine curve normally starts at 1 and goes to? Starts at 1 and goes to? Usually goes down to 0, right? So what is 0 times -2? It's 0, but we treat this like it's the x-axis, so my point would be here, okay? Now, really quickly, we can understand how this can become confusing when we're reflecting it, shifting it, doing all this stuff to it. This would be a prime example for one that I would probably suggest. We go -2 cosine of x plus 3. Now I'm going to go ahead and throw a degree in here because I like working in degrees. But the problem is that I switched everything up a minute ago. So I now need to go back to this and change this back to -360 and +360. So this is what my curve should look like. Of course, going to the table is only going to be helpful if my table starts at the beginning and jumps by 90 degrees each time. And now I got a really, really nice, helpful table. So what does that mean? That means my graph should go 1, 3, 5, 3, 1, 1, 3, 5, 3, 1, 3, 5, 3. 1, 3, 5. Okay, so we get the idea. Hopefully we got the pattern. So it's supposed to go 1, 3, 5, 3, 1, 3, 5, 3, 1. And we can use the calculator to help us do that. And that is my g of x. -2 cosine of x plus 3. So I hope we're getting the idea that the radians and the degrees, we can look at a degree graph to create a radian graph or vice versa, right? So we're speaking in interchangeable languages when we do that, I think. State the ranges of each. What is the range of the blue graph? Lowest to highest is -6 to 2. And the range of the green graph was 1 to 5, right? Because it kept doing what? 1, 3, 5, 3, 1, 3, 5, 3, 1, 3, 5, right? The minimum value, oh, I know this one, 1 and 5. And this is going to be -6 to 2, right? So, if I wanted to know the maximum value of this curve, right? If I want to know the maximum value of this curve, watch what I'm going to do. Do we all agree that that's the midline? Now, I don't even care what this thing looks like. I just know that it has an amplitude of 4, right? Which means from this midline, I'm going to do what? I'm going to have points that go up 4. I'm going to have points that go down 4. Everybody agree with that? So if this is -2, -2 plus 4 means that this curve is going to have a maximum at 2. -2 minus 4 means it's going to have a minimum at negative 6. This said that it's going to reach a maximum value when x, oh crap, okay, hang on. Okay, well, we actually have to solve it now. Okay, so a maximum value, what is the maximum value of this graph? 2. So what do I need to do? I want to know when that happens. This is a trick question, guys. This says what? The graph will reach a maximum when x equals. This doesn't say what is the maximum. It says at what value of x will I get at the maximum. So now I got to take the curve and set it equal to the max. I want to know when the curve equals the maximum. Can I solve that equation? We haven't solved an equation yet. Let's see if we can solve an equation. How would I solve this? I got to solve for x. Give me a step. Add 2. Divide by 4. And I get sine of x equals 1. When does sine equal 1? When does sine equal 1? Oh, bless you. When does sine equal, when does sine equal 1? At 90 degrees. Is that a choice? Okay, well, where is pi? Pi is right where? Here, right? Is that any good? No. 2's no good. That's like the what? That's the trick, right? Where's 2 pi? Isn't 2 pi the same as 360? So isn't 2 pi here? Is that any good? No. What's negative 3 pi over 2? Negative 270. Negative 270 brings me around to that. Guys, what's another way you could answer that problem? Could I have just taken the choices and plugged them in to see which one gives me answer? Yeah. Okay. So we